this will just be a couple of extra problems, one over volumetric analysis and one over how to write ionic equations, net ionic equations, and identify spectator ions. Okay, so if we take this problem, sodium carbonate plus calcium hydroxide to make calcium carbonate and sodium hydroxide. So let's say I tell you that you start with 0.150 molar calcium hydroxide and 49.8 mils of it, and that it requires 14.9 mils of sodium carbonate to react with it. Then what is the molarity of this sodium carbonate? Solution. And so again, this is just a stoichiometry problem, but using volumes rather than grams. And you got three numbers to work with. So on these calculations, you don't need molar mass unless the question asks you about grams. In this case, it doesn't. If it asks you just about volumes and molarity, then you don't need molar mass. If it happens to ask you about grams of something, then you're going to need molar mass at some point. But you have those three numbers to work with, so you're going to work with these two numbers first of all. So 0.150 molar means 0.150 mole of calcium hydroxide per 1 liter of solution. And if you multiply by the volume, so take the 49.8 mils and convert it to liters, so 0.0498 liters, so divide by 1,000. Then you have 0.00747 mole of calcium hydroxide. Okay, so now once you have that, so now you go back to the equation. And so this will be the point where you use the molar ratios. And so of course you'd want to make sure to inspect the equation, make sure the equation is balanced, in case I didn't give it to you balanced. You have to balance the equation before you do anything if you're doing a stoichiometry problem. In this case it's already balanced, so your job's a little bit easier, and it's a 1-to-1 ratio, so every 1 mole of calcium hydroxide reacts with 1 mole of sodium carbonate. But we can still set up the dimensional analysis so that you can see how the math works. So 1 mole of Na2CO3 would react with 1 mole of calcium hydroxide. So you're going to need 0.00747 mole of sodium carbonate. And so the question asks, what is the molarity? Well, you have your initial told you that you started with well, it required 14.9 mils of sodium carbonate solution to react with the calcium hydroxide, and that 14.9 mil contains 0.00747 mole of sodium carbonate, so you can calculate the molarity. So molarity is moles divided by liters, so 0.00747 mole of sodium carbonate. So convert your 14.9 mils to liters, so divide by 1,000. So 0.00747 moles of sodium carbonate in 0.0149 liters. So then your concentration is 0.501 mole per liter, or 0.501 molar. Okay, and if we take another example of ionic equations, net ionic equations, and molecular ions, so this will be a molecular formula, a molecular equation that's given to you. So let's take that equation and write it as an ionic equation instead. So anything that's aqueous needs to be split up, ionized. So if you put that in water, it's going to dissolve since it's aqueous, and since it's an ionic compound, it's going to split up into cations and anions. So NaOH would look like then Na plus aqueous plus hydroxide, OH minus, and then ammonium carbonate, so NH4 plus aqueous plus Br minus. And then anything that is gas or liquid or solid, right, you don't ionize it, so you keep them together. But the NaBr is aqueous, so you need to split it up. Right, but you would keep the ammonia together. And you would keep the H2O together. Okay, so that would be the ionic equation. And so now we can take that and write the net. The net ionic equation, and that's just going to show that's only going to show the things that changed. So what did not change? So Na plus did not change, right? It's the same on the left and the right. So that's going to drop out. Bromide did not change. Br minus aqueous on the right and the left. So that's going to drop out. And everything else changed. So OH minus, there's no OH minus on the right, so that changed. NH4 plus aqueous, there's none of that on the right, so that changed. So now the net ionic equation is OH minus aqueous plus NH4 aqueous became NH3 gas plus H2O liquid. So basically the hydroxide reacted with ammonium. So OH minus reacted with NH4 plus and made NH3 and H2O. So that's your net ionic equation. And then lastly, we can identify the spectator ions, which is going to be what did not change, Na plus and Br minus. Nothing happened to them. They were just watching the reaction. They didn't participate. So they're the spectator ions.